We've put on some competitions for adversarial question writing in the past, Trick Me If You Can, Fool Me Twice, but I realized that one common thread through all of these fun exhibitions of adversarial question answering is that we didn't do a good job of priming the pump to make sure that people know how to start. We gave them a keyboard, a computer they could write against, and told them to have fun. So my goal today is to change that, and to talk about some of the strategies that people have used to fool computers in the past. But first, a couple of disclaimers. And I can't stress this enough, this is not meant to be an exhaustive list. What we really want is for people to be creative and to show us new ways of tricking the computer. So hopefully these examples will inspire you to do something new that isn't on the list of about a dozen ways to trick a computer that I'm going to go through. And I'm not going to target specific systems here. I'm focusing on methods that seem to work generally across a number of different systems. At least as of late 2022 when I recorded this video. That being said, as we go along, I will show you the answers from the QA system that won the competition I held in an undergraduate computer science course here at the University of Maryland, CMSC 470. Check out the link in the description to see it taking on Yogesh Raut, Victoria Gross from The Chase, and Yannick Kilcher in the final exhibition for the course. It's a really good system on normal questions. But hopefully I'll convince you that it isn't perfect based on some of the questions that can stump it. However, questions that nobody can answer aren't very interesting. What color shirt did Jordan Boyd Graber wear on Tuesday isn't a very interesting question. For the record, GPT-3 says blue when the answer was actually orange. What's more interesting are questions that computers cannot answer, but some skilled humans can. In the lingo, we want questions to still be discriminative for humans, to separate skilled players from unskilled players. In English, we want questions to be answerable based on knowledge, not chance. These should still be good, unambiguous questions. Okay, let's jump in. Probably the easiest way to fool a computer is to write about something it doesn't know. For example, GPT-3 still thinks that Donald Trump is the president. So if you ask questions like, what is the capital of the state where the US president was born? A smart but out-of-date system might answer Albany instead of Harrisburg because it thinks that Donnie from Queens is still president instead of Scranton Joe. But GPT-3 didn't even get that. It answered Washington, D.C. because that's more associated with the president than any other city. In addition to not being up to date, models sometimes lack common sense. So if you ask something like, Mary can't eat Cheerios or a McFlurry because she lacks what protein, requires you to know that most people eat Cheerios with milk and that a McFlurry from McDonald's has dairy, soft serve, in it. GPT-3 answers with gluten, which is a protein associated not with being able to eat stuff, but it isn't lactase, which helps people digest lactose. In the computer science literature, it was quickly recognized that asking simple questions like, what is the capital of Hawaii? It's relatively easy for a computer to answer. As is a question like, what state was annexed by the Newlands Resolution? But if you put them together, what is the capital of the region annexed by the Newlands Resolution? It becomes harder for a computer to answer. If you know the answer, leave it as a comment down below. Like with many of the strategies we'll talk about today, they often work well in combination with each other. Multihop probably first and foremost among them. You can take one of the other strategies, combine it with a multi-hop, and often get a question that stumps the computer. Okay, next up, oblique references and paraphrases. Humans often have an easier time figuring out what's going on in questions that are indirect, but nevertheless unambiguous. Franco Harris caught it in 1972. Who threw it? In this case, we're talking about the immaculate reception that Terry Bradshaw threw. GPT-3 doesn't even try to answer. But a human can likely figure out that in this case, we're talking about the immaculate reception that Terry Bradshaw threw. Hoo-hoo. and that Franco Harris caught to score a touchdown. It's more challenging for a computer both to figure out that you're talking about a play in a football game and to figure out who threw the Immaculate Reception. Again, a multi-hop question. You first have to figure out that you're talking about the Immaculate Reception, then figure out who threw it. More generally, you can think about how to paraphrase stock clues like "threw herself from a cliff." This phrase appears in a lot of questions about birth of a nation, but "flung herself from a precipice" does not, which makes the question harder both for humans who study stock clues and for machines who are just doing a Control-F on a web page, essentially. One type of question that sometimes appears in trivia competitions that seems to pose a big problem for systems is finding the common link between entities. Take, for example, this question. An 1842 story about a St. Petersburg clerk who loses his most valuable possession shares its name with what John Hyatt song that instructs the listener to take off that silly thing? A computer struggles to figure out what's valuable to a Russian in winter, and what's a silly thing that you might take off. The challenge here is to not make any individual piece easy enough for a computer to answer, but to make the overall collection of possibilities something that a human could piece together and triangulate to get to the answer. Another way of framing this is like the mystery themes that you often see in pub quizzes, where you sometimes need a handful of examples to spot the connection between all of the individual clues. What do the cigarette brand from The Simpsons, which has a mascot named Menthol Moose, the pen name of the screenwriter for the film Juno, and the future president who killed Charles Dickens in an 1806 duel have in common? You can start figuring out the individual clues. You get Laramie, Diablo Cody, and Andrew Jackson. What do they all have in common? Well, maybe you could piece together that they all name cities in Wyoming. Next up, logical reasoning. The predominant question-answering approaches for questions focus on retrieval and pattern matching, and are relatively weak when it comes to reasoning. Let's take a look at a question. What Lonely Island song contains a line that rhymes with "like Leo" and is also a contrapositive of the song's title? In case you forgot, a contrapositive of P implies Q is if not Q implies not P. So if we have a song lyric, I'm the king of the world on a boat like Leo. If you own the show, then you show not me-o, would be the contrapositive of I'm on a boat. And GPT-3 says Stockholm, which I don't think is a Lonely Island song. Similarly, what Longfellow poem contains an if statement that would be evaluated as to? He said to the friend, if the British march by land or sea from the town tonight, hang a lantern aloft in the belfry arch of the North Church Tower as a signal light, one if by land, two if by sea, and on the opposite shore I will be. And since the British did indeed sail by sea, there were two lights. Write the name of the poem this comes from if you know in the comments. Now, it could be that I'm the only kind of person who would appreciate this kind of question, but it's indeed something that computers struggle with. We've also seen questions asking about familial relationships. For example, if my second cousin has a son, what's my relationship to his son as well? And that seems to trip up computers too. By the same token, computers struggle with mathematical reasoning. Back in the early 2000s, there was a trend of taking this to extremes and just multiply everything by 0. So have a long stream of clues and then multiply that by the number of gold medals Tanya Harding has won, which I thought was dumb. But there are less crazy ways to do this that would still challenge a computer. What would you need to multiply the number of Argentina's World Cup victories to equal Italy's? Again, write the answer if you know it in the comments. Or together, what two countries' populations make up more than a quarter of the world's population? So full disclosure, I wrote these questions assuming that I, a computer science professor and trivia nerd, could confidently write questions that could stump a computer. I failed here, so it's hard. Maybe we could have fixed this with paraphrasing, adding in some numbers, multi-hop, who knows. But I thought it would be a useful thing to leave in here to show that it ain't always easy to stump a computer, even when you have a fair bit of practice, and these systems are getting better and better. Okay, but let's move on to the next technique, misdirection. Sometimes a question can be relatively straightforward, but if it doesn't match the kind of question that the system expects to answer, it can throw it off. This happens for humans too, which is why these kinds of questions are sometimes called stealth questions in the trivia community. So for example, in a recitative, the singer of what song compares himself to Don Juan and brags of his conquest from here to Hong Kong before requesting the titular digestif from Jean-Marc Clanet. As always, please leave your complaints about my French pronunciations in the comments. It boosts engagement. That digestif is Carvassier, so this would be Busta Rhymes past the Carvassier. The way this question is phrased, it makes it sound more like an aria than a rap song. So some systems are misled and pull up things that are more about operas than rap songs. And indeed, GPT-3 answers the French opera composer Lully. Similarly, in our Fool Me If You Can competition, we had a question about Bill Clinton focusing on pop culture that sometimes threw off a system. Who was replaced by a drunken animatronic bear from the Country Bear Jamboree on The Critic and was edited to appear in the film Contact, which prompted an angry statement from Mike McCurry. And GPT-3 answers, which, ain't a bad guess. If you know the answer, write it in the comments. My favorite example of a question that tricks computers is when a valid question is embedded somehow in a longer question. So, for example, what author opens Crime and Punishment could be in a question about Dostoevsky. But if you zoom out to see this question in its entirety, a character in a work by what author opens Crime and Punishment to discover that it has become the brothers Karamazov. A human knows that this isn't Dostoevsky, but many computers miss the forest for the trees and become just as confused as the narrator of Cogwheels and go for the obvious wrong answer. And if you know what Japanese author wrote Cogwheels, write it in the comments below. Well, our questions are in English, and although systems do seem to have some ability to process multilingual inputs, it doesn't work as well as when the question is entirely in English. And so, again, you don't want to do things that would completely throw off an English-speaking question answer, but a reasonable question might be, what actor spoke the lines, mit dem Angriff Steiners wird das alles in Ordnung bringen? And here again, it's combining this with other clues to also make it a multi-hop question. You need to figure out the movie, what character in the movie said it, and then who played him. Write the name of that recently deceased actor in the comments if you know his name. Okay, so I think that's enough techniques for how to trick a computer, but before I end the video, I want to mention some things that you shouldn't do. The first, which should be obvious, is that you shouldn't copy-paste text from anywhere. First, it's bad practice. Secondly, it makes it much, much easier for some computers to cheat on the question. While one system might not have crawled the piece of text that you copy-pasted, some other system might have, and that makes it almost trivial for it to answer. As I mentioned before, we want to trick computers, not humans, so we shouldn't do things that would trick a human. For example, back in the bad days of Quiz Bowl at the end of the 20th century, you sometimes had questions like, it had North America's first social democratic government and has cities like Moose Jaw and Lloydminster. For 10 points, spell Saskatchewan. We're answering Saskatchewan, which seems like the answer from the first sentence would be incorrect. You have to actually say S-A-S-K, and I'm not going to spell that. In other words, the question should still be good. What's the capital of Georgia would perhaps fool a computer if you gave the answer of Atlanta rather than Tbilisi. That isn't a good question. Ambiguous questions are still bad. A skilled human should still get the answer right. If Yoga Shrout would complain after you submit your question, it's a bad question. Remember that our goal here is to write good questions that challenge computers more than humans, but humans should still enjoy and appreciate the questions. All the rules of good question writing still apply. Be specific, make it clear what you're looking for, and reward real knowledge. I'm hoping that these sorts of questions can help reveal the prowess of human trivia players, challenge computers, and be a lot of fun. But that can only happen with your help, so good luck in writing your questions, and don't forget that this is not a complete list of tactics. We're depending on your ingenuity to find new ways to reveal differences between man and machine. To find out what competitions are coming up, check out the Quanta webpage linked below, where Quanta stands for Question Answering is Not a Trivial Activity. This is just one video from a course that I'm teaching. If you want to get the whole context, check out the course webpage linked below. There you can find all of the videos in the right order. YouTube likes to show you older videos out of order, homeworks, exercises, and recommended readings. And if you want to help other people find videos like this, please be sure to like and subscribe to provide a big gradient to the algorithm.